Hi sir, we are from Group 6. Our project title is Internet of Things IoT based home appliances control. The problem statement of our project is the existing situation creates difficulties in managing and controlling many appliances in home, causing inconvenience and time consumption for house owners. Existing remote control solutions frequently need complex installation and configuration procedures, making them inaccessible to regular user. Furthermore, property crimes, particularly burglaries, continue to be a major concern in Malaysia, with residential theft being widespread. Homeowners require effective ways to deter theft and improve home security, especially while their properties are vacant. Furthermore, there is a lack of understanding among customers regarding the power use of their appliances, resulting in increased energy consumption and higher bills. To overcome these difficulties, an effective and user-friendly solution that allows house owners to remotely operate their appliances using a single mobile phone is required. Project objective. First one, enable user with convenient and easy to use solution that allows them to remotely control their home appliances using their mobile phones from anywhere in the world. Secondly, creating one place control panel for different devices where user can monitor their home, providing with greater control over their home appliances. Third, to automatically control the appliances based on the motion sensor and light intensity present from time to time. And our project scope is Blink will be used as mobile control and monitoring system, and light dependent resistor LDR is used for measuring the light intensity present at home to turn on or off the light automatically. PIR sensor will detect if there is any motion to control the light automatically, the indoor and the outdoor light. And microcontroller node MCU is used to input the sensors and control the appliances through the relay. Communication medium Blink is used as a remote to control the home appliances such as indoor light, outdoor bulb, fan, and socket outlet.
So good day, sir. My name is Bahirathan. Today I am here to explain about the coding of uh, of our project. Over here, first of all, there are few parts of this coding. First of all, I want to explain about the initializing node MCU part. So over here, we define Blink template ID, Blink template name, and Blink auto token. This is it's like the verification ID for the Blink cloud to enable us to control the whole Blink dashboard and an app from the node MCU. And then over here we define the the blink print serial, which is basically a serial print of our Arduino IDE. And then include library ESP8266 Wi-Fi.h, and then include library blink simple ESP8266.h is the libraries which work together for us, so that Node MCU and then the blink cloud can be connected and could work together. And then we also redefine each and every relay pin according to the pins they connected in our Node MCU from D1, D2, D3, and D4. And then we also define every sensor, which is LDR sensor, which is connected to pin A0, and then PIR sensor 1, D6, PIR sensor 2, D7. And then we also stated the Wi-Fi network which we connected over here. The Wi-Fi network which our project currently connected to Vivo 1919, and then the password of the connected Wi-Fi also should be stated over here. And then initial mode equals to 0. This part is mean the initially when the node MCU start to work, the mode of the node MCU is 0. And then PIR data also 0, PIR data 2 also 0, which means the motion sensor as the node MCU started to work, there's no motion is detected. And then we have the blink timer over here, defined as timer. This blink timer is used to for the sensors to enable some functions which later on come in the code, so that it could send a certain amount of data for a certain period. For the second part, we have blink write functions over here. So basically, blink write over here we have V1, which means which virtual pin 1. So virtual pins are software-defined pins that enable communication between Blink app and our hardware. It's act like a bridge between real world and to Blink app interface. So we have relay 1, relay 2, relay 3, and relay 4. This V8, which basically mean the mode we gonna select in our app. So after that, we have mode white setup function. So the white setup function basically have all the output and then the initial state of output. So as Anode MCU started, we stated the relay 1 until relay 4 is the output, and then relay 1 until relay 4 is in high state, which means the relays are in off state. So we code it over here, and then say serial begin over here for us to if there's any value which gonna print in serial monitor of Arduino IDE, it will be this function is enable us to see the values by the serial monitor is setting up to 115200 baud rate, and then blink begin over here is a function that enable the system to start up, and then timer dot set interval 500L send sensor. This basically means later we have another void. It's called void send sensor. So this function means every 500 millisecond the void send sensor will work. After that, we have a void loop, which stated blink run and blink timer run. So blink run basically in order to the blink system always keep on connected to the Node MCU, and then the timer run for us to receive data to send data from Node MCU, which is our census value. So this is the last function of this whole coding, which is void send sensor. So this void send sensor is so crucial for the uh, for Blink to receive data from sensors, and then also for Blink to work on its automatic mode, auto mode. So first of all, we want to integer of LDR data equals to analog read from LDR sensor, which means the LDR data is the reading from LDR sensor, and then same over here, constant integer of PIR data one is data which we receive on PIR sensor one, and then same goes to the PIR sensor two. So after that, if mode equals to high, this function means if the mode of our system is high, which is mode in automated mode, this whole function will work. So first of all, if the LDR data is lower and equals to 500, at the same time the PIR data is high, which means the room is so dark. At the same time, there's a motion present on the PIR sensor one. The virtual read V equals to low, and then the digital write relay one underscore pin is equals to low, which means the relay one will turn on. So the light bulb will turn on. Else the virtual write v1 equals to high, and then relay one underscore pin equals to high, which means if both of these conditions don't follow, the relay pin will be remain off. The light won't be turning on. So after that, we have a outdoor light bulb automated post automation code. So if PIR data 2 is high, which means is any intruder over there, and then the motion detected in the PIR sensor 2, so the virtual read V2 will be low, and then the relay pin will be low also, and then delay will be into 10K, which means 10 seconds. So this whole thing means if there's any intruder, the relay will turn on, and then the relay will set to turn on for 10 seconds until the motion stops. So if the motion didn't stop after 10 seconds, the same thing will follow again and again. So if there's no intruder, there's no the PIR data didn't like PIR motion sensor didn't detect any motion, the V2 will be remaining high, the relay pin will be remaining high, which means the light will be in off. So this is only for the automated part. So lastly, we have the virtual write V5, V6, and V7, which are respectively for LDR data, PIR data, and PIR data too. So this whole code for Node MCU to send data from Node MCU to the Blink interface. So the same thing will be stated over here. According to relay 1 is V1, relay 2 is V2 until the LDR data, and then motion data 2. So this whole part is to us to get connected with the web dashboard. So over here, so same thing is goes to our phone. This is mainly I'm currently showing the web dashboard. The same thing we can control in our smartphones also. That's all for the coding part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is AHMAD DURRANI, the RUBAA'I, student number EC21119, and I want to share with everyone my Group 6 software simulation demonstration. And this is the schematic diagram of our project in Project 8. As you can see, we have 3 sensors in total, which is LDR sensor and 2 PIR motion sensor. This is a light to help simulate the environment when it is bright or not, and this is to show motion and non-motion. This is the Node MCU, our main controller, and also the component to and our component to connect to Wi-Fi. And this part is the relay. And as for our output, we have lamp 1, which is an outdoor lamp, lamp 2, which is an lamp, which is an outdoor lamp, fan, and also the power socket. This is the power supply to all the output. Okay. Unfortunately, for this schematic diagram, we cannot do the simulation because the MCU within Practice 8 is unable to be programmed. So we cannot run a simulation for this one. However, we prepare simulation using Arduino Uno to simulate the controller and Wi-Fi connection. So in this case, there is already a motion and a light sensor. And let's simulate by controlling through our blink. So first one, for indoor light, as you can see, it changes and there is now a simulation for light being turned on. Let's turn that off and turn on outdoor light. So now lamp 1 is turned off and lamp 2 is turned on, which is an outdoor lamp. Now let's change to fan. As you can see, there is a movement in our lamp, which is showing that the fan is turned on. And lastly, our last output is the 3-pin output for power socket. Looks like there is a slight delay here, but at the end it will turn on, and the power LCD socket will have a different value showing that there is a current flowing. So that's all for simulation.
Okay, now let me demonstrate our prototype. In this project, we got two modes, which is manual and also auto. First, we will demonstrate the manual mode. So we will turn on the every switch in Blink app, so we can see the appliances turn on and turn off. First, indoor light, and then outdoor bulb, fan, and also socket. Okay, and we turn off every switch. Okay, now we change it to auto mode. Okay, on this auto mode, the indoor light will turn on when the room is dark and PIR motion sensor sense any motion. So now we can assume the room is dark and the motion is detected. So the indoor light will turn on, and it will turn off when there is motion and also the room is bright. Okay, next for the outdoor bulb, it will turn on when the PIR motion sensor 2 detect any motion. Okay, you can see the outdoor bulb is turned on when the PIR sensor motion 2 detect the motion, and it will turn off when there's no motion in PIR motion sensor 2. Okay, that's all for prototype demonstration. Thank you.
So our next topic is the conclusion. To summarize, all objectives of the project set beforehand have been achieved. The hardware sensor will detect changes and automatically send signals for controller to turn the home appliance on or off, whether it is the changes in weather, personnel in the space, or in the environment for comfort and security. Additionally, the system is connected through Wi-Fi connection to allow users to control home appliances from distance, increasing the usage and ease to the user. They are all successfully developed. The system developed is tested in real time, and the analysis of data collected from the test showed that distance range detection capability and its reliability can be accurately detected until the range of 700 cm and 10 cm for the case of PIR motion sensor and LDR light dependent sensor respectively. Besides, the time taken for PIR motion sensor to properly detect motion ranges from 3 to 5 seconds depending on the distance of the movement detected. The accuracy might be influenced by the factor of environment, condition, and other creatures passing through. During testing, there are conditions of temperature and sunlight exposure involved, and cats passing through, which will be detected by the sensor and thus giving impact on the overall reliability of the system. A user-friendly user interface designed through Blink software is successfully developed in the mobile application in which user can interact with it to send signals and commands. However, it is still lacking in terms of indicating the appliance's condition to help users in making decisions. It also lacks navigation functionality to help user to differentiate between home appliances located to which area control button where there is a large amount of appliances. Next, let's look at our recommendation. There are some recommendations which can be implemented in the future to improve the already pre-existing system developed. Firstly, to increase the reliability of the system, it is recommended to add a recognition system to identify between human and other creatures' movement so that the system will only react to the action of humans. This can be done by implementing a radar sensor with specific system to eliminate the error due to non-human movement. Thus, its accuracy and reliability can be improved. Furthermore, to improve user experience when using the system, an additional feature can be added into the Blink software, whereby it classifies the appliances according to their room for easy identification and ease of use. So that's all from us. Thank you.